Okay, new chapter, new topic, chapter 3, logic. So we're going to learn and understand what logic is. We're going to build it up from the very, very basics. Logic is, in a sense, what fundamentally underpins the way that we speak, the way that we communicate, at least in terms of facts. So for example, the basic element of logic is the statement. So in logic, a statement is something that is either true or false. So for example, this is a math class. That's a statement. Is it true or false? That's true. It is raining. That's a statement. Is that true or false? That's false. At least right now. Okay. This is not a statement. Do the dishes. Is that true or false? Yeah, it has no value. It's not true, it's not false. It's nagging. Exactly. But this, as far as logic goes, this is not a statement. And logic is comprised of little statements that are built out of statements that are either true or false. Okay. Now, of course, we want to be able to say things that are a little more complicated than this. Noun, verb, noun. That'd be very boring if those are the only sort of things we could say. So how do we make more elaborate formations? A compound statement. What is a compound statement? This is one or more statements that are joined with connectives. So you might ask, what's a connective? Okay. First example of a connective is the word not. So let's apply that. Instead of it is raining, it is not raining. By the way, what is the value of this statement? This is now true. And is a connective. So for example, let's take the statement, I am running late. Let's take the other statement, I am in trouble. I am running late and I am in trouble. Okay. Now, is this true, at least right now? Right now it's not true. Okay. There's also the connective, which we started talking about a little bit earlier, or. So let's take one statement. Today is Tuesday. Okay, that's a good question. So, is it? Is that a statement? It's a question. It's neither true nor false. So not a statement. Clever, but not a statement. Okay. So let's take the first statement, it is Tuesday. The second statement, I have more time to do my homework. So today is Tuesday, or I have more time to do my homework. And the last sort of connective is, it's called if-then. If you beat me, then pigs must be flying. Okay. So I presume everyone has ever used the word not or and or and if then. I presume that you've used this in speaking in your life ever. I presume everyone has done that here. Yes. So, but that actually gets to what I wanted to say, which is the way that you have used it may or may not agree with the way that it is interpreted in logic. Okay. So I want to talk about that. I want to start talking about that a little bit right now. First, I want to show you the notation for these things. So what is the notation? Let me see. So I want to show you the notation for these things. So now, as a way of introducing you to the notation, I want to remind you that in algebra, we use x, y, and z as variables that represent numbers. We're going to do the same sort of thing in logic. In logic, we use p, q, and r as variables to represent statements. Now, in algebra, do you have to use x, y, or z? Can you use something else? You can. We just usually do. Same thing in logic. We usually use p, q, and r. Can you use anything you want? Sure. Okay. Operations. In algebra, we have operations such as plus and minus. In logic, we have these things, which are, you can call them operations, they're generally called connectives. Textbook calls them connectives. So what's the notation? For not, it's a little tilde. For and, it's this little symbol which we call caret. Because of carrot top. For or, it's a downward pointing caret. And if then is an arrow. So how do we, when we have statements like the ones that we've talked about so far, how do we rewrite these in terms of notation? So let's do some examples. Okay. Barack Obama is president and he lives in DC. So let's rewrite this in notation. So first of all, what are the statements? What's the first statement? Okay, Barack Obama is president. How should we represent that? Give me a variable or an abbreviation. B. Great. So B is now that entire first statement. And what's the second statement? He lives in DC. Okay. So what notation can we use to represent that? D. Great. And what is the connective here? Yeah, the connective is and the notation for that is the up caret. So we write it like this. So now again, of course, when you write B and D, this assumes that we all know and agree what B and D stand for. So in this case, B stands for Barack Obama is president, and the D stands for, I'll just say, Obama lives in DC. So that's our first basic example. Any questions? Okay. I will watch the game or I will leave. So how can we write this in notation? So W or L. Or if you like, watch or leave. Okay. Now let's go the other way. All right. I'm going to need another. So let P be the statement, I like shoes. Let Q be the statement, I like the circus. Rewrite this in, so rewrite in words. Now first of all, what does that say just in notation? P or not Q. Okay. And so, okay, so I noticed from something you said, notice for obvious reasons we're never going to use V, the letter V, to represent the statement, because that would be too confusing. It looks too much like that. Okay. So now, how do we P or not Q? How are we going to rewrite this in words in this case? I like shoes, or I don't like the circus. That's it. So that's the idea. And, oh. What about this last one? Let P be Palin was president, and let Q be I would die. So, if Palin was president, then I would die. Okay. So, in particular, notice how it's P arrow Q. That's the same as saying in words, if P, then Q. So there's, if you like, it's an implied that there's an if before the P, and then it's then Q. Does that make sense? Okay. Next, quantifier. What is a quantifier? A quantifier expresses how many items have a certain property. Now by how many, I don't mean a precise number, but I mean it in this way. Logic means it in this way. There are three quantifiers. All is a quantifier. So, for example, all bankers are rich. Notice that this could be written in an equivalent way in English using the word every. So how would you say a statement using the word every that would mean exactly the same thing? Every banker is rich. It's the exact same statement. Okay. That's the first quantifier. Second quantifier, some. As in, some TV channels are in HD. Now, this is one case where the way that we use a word in English may not line up exactly with how we use it in logic. In logic, the word some means exactly the same thing as at least one. So an equivalent way of saying this is at least one channel is in HD. So notice that this would cover, for example, if there's one channel in HD or if there are 10,000 channels in HD. Logically, you would represent both of those by saying some channels are in HD. This is different. What some is meant to be used as is that it's different from all, and it's different from our last quantifier. Take a guess. What's our last quantifier? None. Exactly. So, for example, no giraffes are short. So remember, there's all and there's none, and everything in between is some. And that's why sum starts at least one. Okay. So we started to talk a little bit about what each of these is and what each of these isn't. So it's a good time to talk about how do you negate a quantifier. So negate. So what does negate mean? Yeah. To make it not true or to make it the opposite. And by the way, we already learned the word in logic for opposite. What is the word in logic for opposite? About 15 minutes ago. It's in English. It's a word in English too. If I say this is a math class, how do we say opposite? Not. Thank you. Okay. So let's see. So for example, what is the opposite of all dogs go to heaven? Now, a cheapy way to do this, right. So a cheap way to do this would just be to stick a not in front. So you could say, not all dogs go to heaven. And it's true that that's the opposite. Okay, all dogs don't go to heaven. This is same thing. This is a little bit tricky. So here's what we mean by the opposite or the negation. Like we have the statement, all dogs go to heaven. Under what condition would the statement, all dogs go to heaven, be false?
If it's one dog, doesn't go to heaven.
Exactly. All you need is one dog that doesn't go to heaven, and that makes this not true. Does that make sense? Okay. Exactly. So the opposite of this is some dogs do not go to heaven. Or if you like, at least one dog does not go to heaven.
Some dog goes to heaven. It's the same thing, right?
It's not the same thing. Because some means at least one, and unfortunately what makes it confusing is that this could include all. Just because, and that this is another thing where logic is different from English. In English, when you say some do, you're implying that some don't. In logic, that's not the case. Strictly speaking, the definition is at least one. It's not making any statement about whether all do, or it's not making a statement about all. All is still possible. So, what we need is at least one dog does not go to heaven. Because that's what we would need to make the original statement false. And as we're gonna get into more next time, logic in a large part is all about saying if things are true or false. So if this statement, if we want to make it false, what would need to be the case? At least one dog does not go to heaven. Does that make sense? Or what's the equivalent of saying at least? Some. Yeah, it would be the same. Hold on. Come along. Alright. Okay, finally. So yeah, equivalently you could say some dogs do not go to heaven. Same thing. Okay, next. What is the opposite of some people have brown eyes? Right. So, well, we want to keep it in terms of brown. So, some people do not have brown eyes. Does that make this statement false? If you know that some people do not have brown eyes, does that make this false? No. So so all people do not have brown eyes. Or equivalently, no people have brown eyes. And notice that in this case you couldn't say not some people have brown eyes. We don't have that in language. Okay. All people do not have brown eyes. Okay. So a lot of you seem to be getting this, the idea of what do you, if you have a statement with a quantifier, what do you need in order to make that statement not true? So that's pretty good. So let's talk about it in general. If you have these sorts of things, what's the negation? If the statement is, if the statement says all do, then what's the opposite of that? Yes. At least one doesn't, or equivalently, some don't. Now, if you have the statement some do, or equivalently at least one is, what's the opposite of that? Sorry? All. What's the opposite of some do? Certainly not all do. All don't. So you could say all don't, or what else could you say? No. None do. Because could you have at the same time at least one is and at least one isn't? You could have those at the same time, so that's not the opposite. So at least one is, the opposite of that would be none do. Okay. Now if you have none do, what would the opposite of that be? Yeah. Some do, exactly. If someone's making a statement that none do, what would the opposite of that be? What would definitely make that false? At least one or some in fact do. None do, that should be doesn't. Okay. Alright. So that's the general formulation, and then given any particular problem you'd have to clean up the grammar. Okay. Any questions? Is there something you'd like to see another example of?